Alright, this is the video where we're looking at periodic table trends for valence electrons, core charge, and reactivity. Alright, so let's analyze what we got here. Let's do it vertically. So you notice here that group 1, the core charge is positive 1 for each of them. And the number of valence electrons is 1, 1, 1, and 1. Group 2. Core charge is positive 2, positive 2, positive 2. The number of valence electrons is 2, 2, and 2. Group 3, the number of the core charge, or the size of the core charge, is positive 3, positive 3. The number of valence electrons is 3 and 3. Group 4, core charge is positive 4, positive 4. The number of valence electrons is 4 and 4. All right, so that trend continues as you continue to move from left to right. So for a particular group, the core charge and the number of valence electrons is the same for all the elements in that group. And it also happens to be the same as the group number. For example, group 5, Group 5A, all the elements there should have a core charge of positive 5 and have 5 valence electrons. Well, when you look at this as an example, you can see, yeah, that's true. Positive 5, positive 5. Count up the number of electrons. 1, 2, 3, 4, 5. Valence electrons here. 1, 2, 3, 4, 5. So every element in the same group has the same core charge and the same number of valence electrons, and both of those values are the same as the group number. So the group number actually means something. All right, so let's analyze this horizontally now. So let's take period 2. You'll notice that core charge goes from 1, 2, 3, 4, 5, 6, 7, and 8 all the way to the right side in group 8A. So as you move from left to right, the core charge is increasing. If you count up the number of electrons, valence electrons, sorry, for each of these elements, we got 1, 2, 3, 4, 5, 6, 7, etc. So as you move from left to right across a period on the periodic table, the number of valence electrons is also increasing by 1. All right, so those are some major trends with respect to valence electrons and core charge. Reactivity is another one as well. These guys here only have 1 valence electron and they have a small core charge, so they're really poor at holding their electrons. They only have 1 to get rid of or to give up, and so it's fairly easy to lose that 1 electron. And because they have a small core charge of positive 1, they have a much smaller hold on these valence electrons. The attraction of the valence electron to a core charge of positive 1 tends to be fairly small, so this electron then can be easily pulled away by another element. But in contrast to that, if you look at group 7A, their core charge is positive 7, so there's a strong attraction between the negatively charged electron and the positively charged core of positive 7. Opposites attract, right? So the larger this core charge, the greater of these electrons are going to be pulled towards the core, or towards the nucleus. So these guys, these valence electrons, which are in fluorine and chlorine, for example, are being pulled very strongly towards the center of the atom. And so it's much more difficult for these guys to lose electrons. In fact, because they have a high core charge of positive 7, they're much better at stealing electrons. They only have 1 extra spot available for an electron, so it's very easy for these guys to steal an electron from another element and put it in that position right there. So these guys are very reactive because they're good at stealing electrons. These guys in group 1 are also very reactive, but they're reactive for a different reason, because they're very good at losing electrons.